Alright guys, today we're going to work on lesson 11.3 out of our book. It's going to be comparing data displayed in box plots. So, the first thing we're going to do is our explore activity, and it's going to show us how to create a box plot and what a box plot is. Box plots show 5 key values to represent a set of data: the least and greatest values, the lower and upper quartile, and the median. To create a box plot, arrange the data in order and divide them into 4 equal-sized parts or quarters, then draw the box and the whiskers as shown. Now, this comes out a little confusing in the book, but in reality, all you have to do is put your numbers in order from least to greatest, and then find the median, find the middle. Once you have the median found, you can then find the median of the numbers to the left of that line and the numbers to the right of that line, and then put another line, and that's how you're going to create your box and whisker. You will get more practice with this, so it will be a little more familiar to you. So our next one says the number of points a high school basketball player scored during the games he played this season are organized in the box plot shown. So you're given a box plot. We need to find the least and the greatest values. Now looking at this, our least value is going to be 15. That's where our lowest dot is found. Our greatest value is where our highest dot is, and this dot is found at 30. So then we need to find the median and describe what it means for the data. Well, our median is where this very center dot is. This is the median of our data. And for this one, our median is at 21 points. So that's where our median is here. Now it says, what does it mean for the data? What our median means is our second quartile, which is what you're also going to hear it. So we're going to write it on here. Second quartile. Think of quartile, think of quarters. Also, you could see it written as Q with a little 2, a little subscript 2. This divides our data into 2 halves. Notice if we draw a line right here, we have numbers on the left and we have numbers on the right. So it divides the data into 2 halves. Excuse me. A lower half and an upper half is usually how you will hear it referred to. A lower half and an upper half. So then it says, find and describe the lower and upper quartiles. So our lower quartile is the median of the lower half. So right here, if we find our numbers, this is the median of our lower half. So this is quartile 1. We're going to write Q1. We're going to use our shorthand. This is the median of the lower half. Now, our Q3, that's where this other line is right here, because remember this is Q2, we'll label it Q2, Q1, so that's going to make this one right here, Q3. This is the median of your upper half. So we need to write that in our answer. Q3 is the median of the upper half. Now we need to actually figure out what these values are. Now notice this one is about halfway between here. So our Q1 is going to equal about 17.5 points. And Q3 is going to equal, let's see, we're about halfway between here. We have 25, 26, 27 and a half. So 27 and a half points. So now, on the last part of this, It says the interquartile range is the difference between the upper and lower quartiles, which is represented by the length of the box. Find the interquartile range. So notice it shows you we're going to do Q3 minus Q1. So when we plug in our numbers, we have Q3 is 27.5, Q1 is 17.5. So all we then have to do is subtract, and we have now found our interquartile range. What they want is just the range from the beginning of the box to the end of the box. That's all that you have to worry about for interquartile range. So flip your page over. You have your first your turn reflect activity. So it says, why is one half of the box wider than the other half of the box? So I want you to pause the video and take a moment and try to reflect and figure out a way that one half of the box could be wider than the other half. This is your own explanation, so we will go over it in class after we work it out. But right now, pause the video and create your explanation. When we get back, we'll work through example 1. Alright, box plots with similar variability. Says you can compare two box plots numerically according to their centers or medians and their spreads or variability. Range and interquartile range are both measures of spread, meaning how far apart your data is. Data sets with similar variability should have box plots of similar sizes. So if your box plots end up looking really similar, then you know that you're going to have a similar variability. If they look completely different and one is really, really big and one is really, really small, then no, they should not have similar variability. So, this one in example 1 says the box plot shows the distribution of time spent shopping by two different groups. So we have group A on the top in green, group B on the bottom in blue. And this is their shopping time in minutes. Notice our label down here on the bottom. A says, compare the shape of the box plots. So, literally, look at them. Compare their shapes. This is just like we did in lesson 11.2 yesterday. The positions and the lengths of the boxes and whiskers appear to be very similar. In both plots, the right whisker is shorter than the left whisker. So they're pretty similar so far. Step B says, compare the centers, just like yesterday. How do their centers compare? Okay, if you look at group A, its median, which is 47.5, is greater than group B's. Group B is all the way over here, which is 40. So that means that the median shopping time for group A is 7.5 minutes more than it is for group B. Last step, it says compare our spreads of the box plots. So we need to actually look at the range of these. The box shows the interquartile range. The boxes are similar in length. They look pretty close to me. So it says group A, we're going to go from 55 to 30. So we subtract, we get 25 minutes. Group B goes from 59 to 32, so it has 27 minutes. The length of the box plus the whiskers is going to show the range of the data sets. So when you subtract everything all the way from the highest number down to the lowest number, that gives you your range. Remember, your interquartile range is just the range within the box itself. Alright, so these two data sets do have pretty similar ranges, and you should be able to look at that and say, yeah, these are pretty similar. So what I want you to do now is the reflection question. So it says, which group has the greater variability in the bottom 50% of shopping times? The top 50% of shopping times, explain how you know. So you need to look at the data and look at which one has a greater variability in the bottom, which one has a greater variability in the top, and then explain how you did your answer. So whatever you thought about in your head, whatever you compared in your head, that's how you need to explain it on the paper. So pause your video, go ahead and answer your question. I'm not going to put the answer on here because so much of the explain how you know could be very different for everybody else. It should be still very similar, but when we go over this as a class, we will go over this reflection question together. Alright, for the your turn number 3 problem, it says the box plots shown the distribution of weights in pounds of 2 different groups of football players. Compare the shapes, centers, and spreads of the box plots. So you're doing the exact same thing right here on number 3 that we did together on example number 2. So if you need to refer back to what or example number 1, excuse me. If you need to refer back to example number 1, go for it. That's why you have this work. That's why you have a section here to make notes on anything that you need. So, pause your video, compare your shapes, centers, and spreads, and whenever you come back, we'll continue on with example 2. Alright, now we're going to look at box plots that have different variabilities. Remember our last one was same or similar variabilities? This one is different. You can compare box plots with greater variability, where there is less overlap of the median and the interquartile range. Example 2 does this very thing. It says the box plots show the distribution of the number of team wristbands sold daily by 2 different stores over the same time period. So notice we have store A right here in blue, and we have store B right here in green. And then underneath the bottom, we have our label, so we know what we are looking at. We're looking at the number of team wristbands sold daily by these 2 different stores. First thing, same steps as before. We need to compare the shapes of our box plots. So store A's box and right whisker are longer than store B's. Notice how long this right whisker is. Notice how short this one is. This one, there's a big difference between these 2. The box is also different. We have a bigger box here, plus it is much further left on our graph, on our number line, than our one on the right. So then step B says compare the centers of the box plots. Store A's median is right about 43. It's going to be about right here in the middle. And store B's is about 51. So we go to our median. Remember, this one in the very center. And it's going to end up right here, which is right about 51. Store A's median is close to store B's minimum value. So about half of the store A's daily sales were less than sales on store B's worst day. That's a pretty big difference. Step C says that we need to compare the spreads of our boxes. We need to compare our ranges. So compare the spread of the box plots. Store A has a greater spread. Its range and interquartile range are both greater. Notice our range all the way from high dot to low dot is much larger than store B's. And the interquartile range, meaning just the range of the box itself, is also larger than store B's box. 4 of store B's key values are greater than store A's corresponding value. So when we compare, notice our quartile 1 is higher than the median. Our quartile 2, our midpoint right in the center, is higher. Quartile 3 and our highest point, they are all higher than corresponding A's corresponding value. So store B has a greater number of sales overall. That's something that you can pull from this data. Now, for the your turn, once again, after I read it, go ahead and pause the video, and then when you come back, we will look at your guided practice questions. So question 4 says, compare the shape, center, and spread of the data in the box plot with the data for stores A and B and the 2 box plots in example 2. So you are going to compare this one right here, the box plot that they're giving you on number 4, to the 2 box plots that we just compared in example 2.